Hello. This will be a demonstration of proposition 36 from book 7 of Euclid's Elements, which tells us, given three numbers, to find their least common multiple, or as Euclid says, the least number which all three of them measure. We're of course given just three numbers, A, B, and C, and what we want to find is their least common multiple, or the least number which all three of A, B, and C measure. We're going to begin by taking the least common multiple of A and B. We're going to call that the number D. So the number D is the least number which both A and B measure. We can of course find D by proposition 734. Now either our number C measures our number D or it does not. If it does, then it's obviously a common multiple of all three of them. That is to say that the numbers A, B, and C all measure D. If then D is not the least number which A, B, and C all measure, then there's going to be some other number which is less than D, which is measured by A, B, and C. We're going to call this the number E. E is going to be less than D, and A, B, and C will all measure E. Now, because A and B measure E, right, we made E in that way in the previous step, and their least common multiple has been taken, that is the number D, we can then say by proposition 735, right, if two numbers measure any number, their least common multiple will measure the same. We can then say that the number D also measures the number E. Now, of course, because the number D measures the number E, the number D has to be less than the number E. Remember, in our third step, we made our number E less than our number D. That is to say that our number D is greater than the number E. So what ends up happening is that the number D is both greater than the number E, and it is less than the number E, which is obviously impossible. And so we can conclude that the number D is the least number which A, B, and C all measure. That is to say that the number D is the least common multiple of A, B, and C. But on the other hand, if our number C does not measure our number D, we're going to take their least common multiple, call that the number E again. So E is going to be, this time, the least common multiple of C and D. It is going to be the least number which both C and D measure. Now, because the numbers A and B measure the number D, and D measures E, it obviously just follows as a property of numbers that A and B both measure E as well. And remember, E was made was created to be measured by C, right? We did that in step 6. So it's clear that E is measured by our three numbers, all of them, A, B, and C. So E is a common multiple, in other words, of A, B, and C. If the number E is not the least common multiple, then there's going to be some number which is less than E and which is measured by all of A, B, and C. We're going to call this the number F. So F shall be less than E, and our numbers A, B, and C will measure F. So then, because A and B measure F, right, we made F in that way, and the least common multiple of A and B has been taken as the number D, it again follows by virtue of proposition 735 that their least common multiple will also measure that same number. That is to say that the number D measures the number F. So then it's clear that the number D measures F, and we made F to be measured by C, so F is measured by both C and D. And furthermore, the least common multiple of C and D has been taken as the number E. So again, we can use proposition 735 and say that the least common multiple of C and D also measures F. That is to say that the number E also measures F. And because the number E measures the number F, it clearly follows that the number E has to be less than the number F. Well, you will remember in step 8 here, we made the number F to be less than the number E. That is to say that the number E is greater than the number F. So again, we find that the number E has to be both greater than and less than F at the same time, which is just absurd. And so we can conclude that our number E is in fact the least common multiple of A, B, and C. It is the least number which is measured by A, B, and C. And so we found the number we were looking to find. We wanted to find the least common multiple of A, B, and C, and we've just found it. D if C measures D, and E if it does not. So we're done with the proposition Q, E, F. Just to give an example of this, In the first case, that would look something like if we have 4, 5, and 10, and we wanted to find their least common multiple. What we would do is we would take the least common multiple of the first two numbers, which here I believe is 20. Yeah, it's just 20, because they're coprime, you can just take the product, of course. So the least common multiple of 4 and 5 is 20. Now 10 does measure 20, and so we can conclude that the number 20 is the least common multiple of 4 and 5. But if we have instead something like 2, 3, and 5, we wanted to find their least common multiple, what we would do is we would take the least common multiple of the first two numbers, that is 2 and 3, and that's obviously just the number 6, again, because they're coprime, you can just take the product. And it's clear that 5 does not measure 6, so again, we'd have to take the least common multiple of 5 and 6, and that would be, well, they're coprime, so you can just multiply them, take the product, and that's the number 30. And 30 will be the least common multiple of 2, 3, and 5. We can verify that both of these are true, so we see that this proposition holds. One final thing to say about this proposition is that it can obviously be extended to as many numbers as we please. You would just continue taking the least common multiple 2 at a time until you've just exhausted all possibilities. That's all I've got to say about this one, so I'll end the video here and move on to 737.